How does the observer effect work? Strange Science explains. Imagine trying to watch a tiny insect on a leaf, but every time you get close, the insect moves away. In the world of physics, something similar happens with particles at the smallest scales. The act of observing or measuring can actually change what's happening. This is called the observer effect in physics. It's especially strange when we look at the universe's tiniest building blocks, like electrons and photons. These particles don't behave like tiny balls rolling around. Instead, they act like waves, spreading out and existing in multiple places at once. When scientists do experiments, they often want to see exactly where a particle is or how fast it's moving. To do that, they use tools like lasers or detectors. But here's the catch. These tools have to interact with the particles. When they do, they disturb the particles' natural behavior. Think of it like trying to measure the pressure in a balloon. The moment you poke it to check, some air escapes, changing the pressure. That's the classical observer effect. But in the quantum world, things get even stranger. When particles like electrons pass through a double-slit apparatus without being watched, they create a pattern on a screen that looks like waves interfering. It's as if each electron is passing through both slits at the same time. But if you set up a detector to see which slit the electron goes through, the interference pattern vanishes. Instead, the electrons act like tiny balls, going through only one slit. The act of measuring collapses the wave-like state into a definite position. This isn't about a conscious observer peering into a microscope. It's about the physical interaction between the measuring device and the particle. This interaction forces the particle to choose a specific state, changing the outcome of the experiment. This effect has puzzled scientists for decades because it suggests that reality isn't fixed until we observe it. It's as if the universe waits for us to look before it decides what it is. The observer effect is behind many cosmic mysteries and strange phenomena in physics. It shows us that at the smallest scales, the universe behaves in ways that challenge our everyday ideas of how things should work. It's not just about tiny particles. It's about the fundamental nature of reality itself. Today, scientists are trying to understand how to control this effect for new technologies like quantum computers and secure communication systems. They're learning how to measure without disturbing, or even how to use this disturbance to their advantage. So, the next time you think about observing something, remember that in the quantum world, just looking can change what you see. The observer effect reveals a universe that's far more mysterious and quirky than we ever imagined, where the act of watching is part of what makes reality what it is.